Hi everybody. So today we're going to work on graphing trig functions, the inverses of the trig functions, and the reciprocals, and we're going to be doing this on the calculator. So I would like you to put me on pause, do the try this. The try this says all I want you to do is to identify the vertical and the horizontal transformation. So the vertical transformation would be the shift that goes up and down. So that would be you're looking for your midline. And the horizontal shift, which is your left-right shift, that means you're looking for your phase shift. So make sure when you look for your phase shift that you do have the number that's in front of the x factored out into front of the parentheses. Okay, so put me on pause and give it a try and then come back. Check your answers. Okay, so number one is y equals 3 cosine 2x plus 5. So there's no shift inside here because there's no plus or minus after the x. So there's no phase shift here. You have to have a plus or minus like number 2 and number 3 have here. So this has a vertical shift, the plus 5. So the plus 5 means that it's up 5. All right, so let's take a look at number 2. So I see that there's no plus back here, so that means there's no vertical shift. There's no up-down shift. There is a left-right shift. So obviously there's a minus, so it is going to shift to the right, because remember when you go left-right, it goes opposite the way you think it goes. But it's not in the right form. You have to factor out the 4. The number in front of x should be a 1. I don't do anything here because it doesn't make sense to factor out a 2. You're still going to have just 2x. All right, so over here I do have to factor out the 4 to put it in the right form to identify the phase shift. So it's y equals negative sine, factor out the 4 times x minus. Now what goes inside here with the parentheses is going to be a pi over. Now you have to think about what you would have to have in the denominator here. What do you have to have here so that when you distribute the 4 here, when you distribute the 4, you're going to get 4 pi over some number. What number do I need that to be so that it reduces to pi over 2? Really, the easiest way to do this is just to multiply 4 times 2, which is 8. Which hopefully that makes sense, because then when I multiply the 4 here, when I distribute the 4, I'll get 4x, 4 pi over 8, which would be pi over 2. Okay, so I do have this shift here, okay, and it's minusing from x, so that means it's to the right, pi over 8 units. Okay, number 3. Again, it's not in the right form, but we have, sorry, my dog is barking. Okay, good. So I shoved a treat in her mouth. She's all good right now. All right, so let's take a look at number 3. So I notice that I do have a shift left and right because I have this plus pi over 3 in here, but that's not the phase shift because I have this 2 that I'm going to have to factor out. And I have a vertical shift because I have this minus 10 at the end. So first thing we're going to do is put it in the right form. So it's going to be y equals negative 4 cosine, factor out the 2x, plus something pi over something, and then I have a minus 10. So what number would I need in the denominator here so that when I distribute the 2 back, I get 2x, 2 pi over what number, and the 2 will reduce with the number and give me a 3. Right, so 6. 2 times 3 is 6. So this number in the denominator has to be a 6. Okay, so we have inside the parentheses, remember we work inside out. So I have a plus pi over 6 to x, which means that's to the left by pi over 6. And then I have the minus 10, which is down 10. Okay, so I am going to give you a couple of those on your practice for later. Okay, so just make sure it's always in the right form first. And just really quickly, this 3 here, if you remember, so when you multiply by 3, remember that multiplying by 3 will actually stretch it. So think about when you have an amplitude of 3, it's kind of like making it go higher and lower. So that's a stretch of 3. Here I have the negative means there's it's a reflection over the x-axis, right? So that kind of makes sense because sign would start down. And here there'd be a stretch of 3 and also a reflection over the x-axis. The 2's here, those are different types of transformations. Those are the transformations that move, that shrink it and stretch it going left and right. Okay, so when you have a 2, that means it's shrinking it by 2 because you're squeezing more, it's more cycles within the 2 pi interval. All right, so let's take a look at the next piece. Okay, so since I'm going to be graphing on the calculator today, and we'll be putting the graphs on a graph, you really do need to have your calculator in front of you. So if you don't, put me on pause right now. Go get your calculator so that you can have it in front of you. Otherwise, you're not going to have any idea what I'm talking about. And you really need to know how to, especially the inverses and the reciprocals, you need to know how to do those on your calculator. Okay, so for us right now, we're going to just use Zoom 7 to help us with the graph. There are going to be times when you do want to put your calculator in radians and adjust the window. That would be when you really want to fine tune your graph, which is really what we did when we did the amplitude, the number of cycles, which is also called the frequency. We did the number of slashes. We did the X scale. Okay, that's when you want to really use the window so that you can adjust the graph accordingly. Okay, but we really just want to see what the graphs look like, especially with the inverse and reciprocals. And I just really want to show you how to graph basically on the calculator. All right, so let's take a look at the first one. So I have here, it's just the basic sine curve. So I'm graphing y equals sine x. So go into y equals on the calculator, right? So we're going to actually graph. Go into y equals. Press sine, type in x. You could close the parentheses. It'll still graph if you don't close the parentheses. Hit zoom, number 7, and you'll see the sine curve. So let's just draw a quick sketch on the graph to the right. All right, so I know it's going up and down to 1. 1 and negative 1. All right, so it looks like this. So this is what you're seeing on your calculator, hopefully. Okay, and we're going to label the ends. Hopefully yours is a little bit neater and equally spaced. So my end here is 2 pi. So obviously you can see on the calculator, they don't give you those intervals. So if you want it to graph correctly, you have to adjust the interval for some of them, especially if you have, like, if you're putting in the cycles, like it's sine 2x or sine 3x, you have to adjust that. So this would be pi, halfway between 0 and pi would be pi over 2, and then this would be 3 pi over 2. And on the right would be negative 2 pi, negative pi, negative 3 pi over 2, and negative pi over 2. Okay, so let's graph cosine. So go back into y equals. Hit y equals cosine x. Hit graph. And again, that's going to 1 and negative 1. You can see the graph on your calculator. So it looks like this. Okay, and let's label the end. So I know my end is 2 pi. Halfway in between would be pi. Negative 2 pi, in between would be pi. In between 0 and pi would be pi over 2. 3 pi over 2. Negative pi over 2. And negative 3 pi over 2. Okay, and let's move it up and graph tangents. All right, so hit y equals on your calculator, type in tangent, and hit graph. So hopefully you remember from the other day, remember I said that tangent has asymptotes at odd pi over 2's. All right, so let's graph this. So my ends are 2 pi, negative 2 pi. The middle would be negative pi and positive pi. Pi over 2. And then we have 3 pi over 2. Okay, so let's draw in those asymptotes. So here my asymptotes are 1 pi over 2 and 3 pi over 2. Negative 1 pi over 2 and negative 3 pi over 2. Remember, they're at odd pi's over 2. So 1 pi over 2, 3 pi over 2, 5 pi over 2, and so on. All right, so your graph will look like this. Remember, the graph approaches the asymptote, but won't cross the asymptote. Okay, so that's your tangent curve. Okay, so you kind of know all that already. I was just showing you how to graph it on your calculator. All right, so now we're going to move on. So you can flip the page, turn your page, or whatever you're doing. And we're going to talk about inverses. Okay, so we're graphing the inverses. So remember, the inverses is when we find the angle on the calculator. So we do second sine, second cosine, second tangent. Remember doing those? Those are those inverse keys here. So we're going to graph those. Now, in order to graph this on your calculator, you have to put your calculator in radians. So hit mode and change from degrees to radians. Hit enter and make sure you're in radian mode. Okay, so we're just going to type it in exactly how we see it. Y equals, do second sine, and you'll see the inverse come up. Hit X and hit graph. Now, this is what you see. Oh, one other thing is this. Remember that inverse means to switch X and Y. Right? We switch X and Y. So if I'm switching X and Y, that means my normal sine curve, if you need to look back at the page before, my y-axis was up 1 and down 1. So now my x-axis is going to be to the right 1. It's going to be to the right 1 and to the left 1. And instead of my x-axis having my radian measure, that's now going to go on my y-axis. So this would be 2 pi. Down here would be negative 2 pi. This would be pi and negative pi. Negative 2 pi over 2, sorry. Pi over 2. 3 pi over 2 and negative 3 pi over 2. Okay, so when you graph this on the calculator, you kind of see this. You kind of see this squiggle here. So the reason why you see that squiggle is because your calculator only graphs functions. It doesn't graph relations. It only graphs functions. Okay, so this graph actually looks like this when we complete it. So it kind of looks like a snake that goes up and down, and it goes through the origin. Okay, so let's take a look at the inverse of cosine. So same thing, go to y equals, and hit second cosine, and hit graph. Let's label our axes, and then we'll talk about the graph. So again, it's a switch of x and y. So on my x-axis will be 1 and negative 1. And I have 2 pi, negative 2 pi here, negative pi, pi, pi over 2, negative pi over 2, negative 3 pi over 2, and that's 3 pi over 2. Okay, so it looks like this. So that's kind of like what you see on your calculator. And again, your calculator only graphs functions, so it's not graphing the entire graph, what it should be. It's only graphing a piece of the function. So let's continue it. It'll look like this. Okay, so that's the cosine curve, the inverse of the cosine curve, sorry. Again, it looks like a snake, but, you know, it has its max at, that is on the axes here. All right, so let's do tangent. All right, so hit y equals second tangent. Hit graph. Let's label the axes. So I just really need to label the y-axis. So this is 2 pi, negative 2 pi, negative pi, pi here, pi over 2, negative pi over 2, negative 3 pi over 2, and 3 pi over 2. All right, so remember, when we graphed before tangent, we had asymptotes. So we have asymptotes again in the same spot, okay, at odd pi over 2s. But remember, inverse means to switch x and y, so now my radians are on my y-axis. So we're going to put in our asymptotes. Okay, those are my asymptotes. So my graph will look like this. And the reason why, remember, it's approaching the asymptote, you're only seeing that one piece is because, again, your graph and calculator only graphs functions. But it actually looks like this. So that is the inverse of tangent. Okay, now we're going to talk about the reciprocals. Okay, so let's talk about the reciprocal. So the reciprocal of y equals sine x. So remember, reciprocal means to flip the fraction. So the reciprocal of y equals sine x is y equals 1 over sine x. But remember, 1 over sine x has a special name, and that is cosecant. So this is y equals cosecant x. All right, so we want to graph y equals... So this is what we're graphing, y equals cosecant of x. Sorry, I just want to change that. So we're graphing y equals cosecant x, but we don't have a cosecant button on the calculator, so we're going to graph 1 over sine x, but that is cosecant x. All right, so before we do that, I just want you to label your axes, okay? So we're ready to go. So we're going to have 1 and negative 1 here. This would be 2 pi, pi, pi over 2, 3 pi over 2, negative 2 pi, pi, oh sorry, negative pi over 2, and negative 3 pi over 2. All right, so let's go to y equals. So go to y equals, type in 1 divided by sine x. You can close the parentheses, you don't have to close the parentheses. Hit graph. And it looks like you get, hopefully you're hitting graph with me, it looks like a whole bunch of U's, up, right side up and upside down U's, okay? And there are asymptotes, okay? So I'm going to put them in red. The y-axis is an asymptote because you could see that your graph, those U's are not crossing the y-axis. There are also asymptotes at pi and at 2 pi, and on the other side, negative pi and negative pi over 2. Okay, so your graph will look like this. So it's going down to 1 here. So put your dots on, put a dot on 1. And it's a U, it goes up like this. And then it's down here. And then this one here. And here. So that is the reciprocal function. Now I do want to show you something that's pretty funky about when you graph this. If I actually draw a graph by connecting the vertices, what I'm talking about are these here. Okay, I'm going to connect them and look what you get. You actually get the sine curve. Pretty neat, right? All right, anyway, so let's move on to the reciprocal of sine. So flip the page or turn your page. Okay, so we have here, we're now graphing the reciprocal of cosine. So the reciprocal of cosine of y equals cosine is y equals 1 over cosine. So remember, the reciprocal of cosine, 1 over cosine, is secant. So this would be y equals secant x. So that's what we're graphing. We're graphing y equals secant x. But notice on your calculator, we don't have a secant button. So we have to graph 1 over cosine x. Okay, again, I want you to plug it in your calculator. So go to y equals 1 divided by cosine x, hit graph. Okay, again, they look like U's. They are shifted. It's not exactly the same. It's close, but they're kind of shifted. So let's label the axes. So we have 1 and negative 1. 2 pi and negative 2 pi at the ends. Pi, negative pi. Pi over 2, negative pi over 2. 3 pi over 2, that's negative. And 3 pi over 2. All right, so again, we have asymptotes. So notice the asymptote is not at y equals 0. It's not the y-axis because it actually goes through the y-axis. There's one at negative pi over 2 and negative 3 pi over 2. And the same thing on the other side. So there's your asymptotes here. All right, so let's graph it. It's going to look like this. This one actually goes, they're very similar. So what you should be looking for when you're graphing is it going through the y-axis, or is it not going through the y-axis? That's really what you should be, looking for to help you out if you're not sure which one it is. That's the key. Is it going through the y-axis or not? Okay, so it looks like that. And obviously, if I kept going, this would kind of like go like this and stuff like that. So now, if I did the same thing I did before with cosecant, and I take all these vertices here, and I connect them, look what I get. It's actually the cosine curve. Pretty neat, right? All right, so anyway, let's move on to the reciprocal of tangent. Okay, so the reciprocal of tangent would be y equals 1 over tangent. And remember, 1 over tangent is cotangent x. All right, so we're going to graph y equals cotangent x, but we don't have a cotangent button on the calculator, so we have to graph 1 over tangent of x. All right, so on your calculator, hit y equals, type in 1 divided by tangent of x, hit graph. We're going to set up the graph here. So while that's graphing, let's set this up. So we have 2 pi at the end, positive and negative. Pi, negative pi over 2. Negative pi over 2, positive, negative 3 pi over 2, and positive 3 pi over 2. So now hopefully, when you saw this really quickly, you were like, oh, it's the same exact thing as tangent. Well, it's pretty close to tangent, but it's actually flipped around, okay? The asymptotes are at pi. The asymptotes are at pi and 2 pi. So let's put that on negative pi and negative 2 pi. Now tangent, when I graph regular tangent, actually goes through the origin. This one doesn't go through the origin because my y-axis is actually an asymptote. And it's actually kind of like backwards. So don't draw this, but if you graph tangent, tangent goes this way, like this. Okay, so this is actually going the other way. So let me erase that. All right, so tangent looks like this. So it's going up. Remember, it's approaching the asymptote but won't cross it. So it looks like that. So that is cotangent of x. It's the reciprocal of tangent. All right, so I know this video was long, but unfortunately it was just a lot to get in one lesson. So I do apologize. And again, there's really not much for you to practice on with this, since it's just calculating you. So I am just going to give you some more practice on graphing vertical and horizontal shifts, and some transformation stuff to identify, like we did at the beginning of the lesson. All right, everyone, stay well. Have a good day. Bye-bye.